Okay, good morning to everyone. I welcome you all for this session. Fine. See, before getting into today's topic, we will recap the content what we have discussed in the previous session. Okay. So in the previous session, we have discussed about the logical group of instruction. Okay. So for a class la we have discussed few instruction from logical group. Fine. Uh, which register, which 8-bit register must be used to complement a data, to complement an 8-bit data. In the particular register, kandipa nama use panni aganum. When I say complement operation, yes, very good. Accumulator, fine, very good. What about the instruction? What about the instruction? What about the instruction? Yes, very good. CMA, fine. CMA, very good. To complement a single bit, that means carry bit. What about the instruction? Complement carry. What about the instruction? Yes, very good. Very good. In classroom 1, many of you are typing. Okay. Classroom 2 la vandu suggest mattum CMA type பண்ணிரு. Yes, very good Diksha. CMC. Fine. Then to set the carry bit, what about the instruction? To set the carry bit, what about the instruction? What instruction we have to use? Set carry. Yes, very good. In classroom 1, many of you are typing. Yes, TC, very good. Fine. Then apart from that, we have discussed 4 types of rotate operation. Okay, rotate accumulator left, not through carry. Rotate accumulator left through carry. Similarly, rotate right accumulator not through carry. Rotate right accumulator through carry. Fine. So that's all about the logical group of instruction we have discussed in the previous session. Okay. Then we have provided an overview. So எந்தெந்த instruction execute பண்ணோம்னா whatever instruction affect the condition of the flag அப்படின்றதெல்லாம் பார்த்தோம். Fine. Then we have continued branching group of instruction. In that we have discussed about the jump, call and return. Fine. Just keyword we have introduced. Today I want to continue the same from the same so that we will have a clear idea about those things. Fine. So what about branch instruction? So today we are going to see about 8085 instruction set. Probably we may continue mission cycle and timing diagram if time permits. Okay. So branching group of instructions. So what are the different instruction we have? JMP, that means unconditional jump. CALL, that means unconditional call. Then RET instruction, unconditional return. Fine. So these 3 instructions are unconditional. Fine. Jump, call, return. Please always remember, whenever I say the instruction call, it is going to call a particular subprogram. That means subroutine. Fine. So definitely at the end of the subprogram, we must use RET, return instruction. Fine. The call and the return instruction are a pair of things. Okay. Whenever I call a particular program, that program must end with a return. Then only it will continue the main routine. Fine. So you have to remember this thing. That means call and return, there is a relation. We have some relation. Fine. Then conditional jump, conditional call and conditional return. Fine. Here some condition of the flag bit is tested. If the condition got satisfied, then it will jump to the particular memory location or call the particular subroutine or return from the subroutine. Fine. These are the things are conditional. Fine. Then we have restart from a vector address instruction. That means software interrupt. Simply we can say software interrupt. RST0 to RST7. Then we have one more instruction, PCHL. This and all about the branch group of instruction. Fine. So already we have gone with jump instruction. So pictorially, we want to animate something so that you people understand well this concept. Fine. So jump அப்படினா என்ன படிச்சோம் நம்ம? First of all, branch instruction எந்த particular register கண்டிப்பா வந்து alter பண்ணும். Content of the particular register will be altered so that the program flow will change. Yes, all branch instruction modifies the content of very good program counter register so that the program flow will get changed. Correct? Fine. Here in this picture you can see instruction 1, instruction 2, instruction 3. It's a jump instruction. It's a branch instruction. Okay. JMP loop 1. Please understand one thing, when we are writing the assembly language program, when we are using the branch instruction, we use labels for better understanding. Okay, because now a program எழுதுறேன் அப்படின்னா அந்த ப்ரோக்ராமோட அட்ரஸ், I mean that particular instruction ஓட அட்ரஸ் அப்படின்றது once when I am assembling the output அப்போ மட்டும் தான் எனக்கு தெரியும். Fine, but when I am writing the assembly code, நம்ம assemble பண்றதுக்கு முன்னாடி just mnemonics யூஸ் பண்ணி எழுதுறோம் இல்லைங்களா instruction. At that time we used to we have to use labels. For example, instruction 6 க்கு என்னோட program transfer ஆகணும் from instruction 3. அப்ப என்ன பண்ணிருக்கோம், JMP loop 1, this we call it as label. இந்த label எங்க tag பண்ணிருக்கோம் பாருங்க, before the instruction 6. கரெக்ட்டா, instruction 6 க்கு முன்னாடி that label with a colon must be there. Similarly, instruction 6, instruction 7, instruction 8, again we are having a branch instruction JMP loop 2. This loop 2 is another label, correct? Yes or no? You can use any wordings for the label, but try to use a meaningful word. Correct? நம்ம லேபிளுக்கு என்ன நேம் வேணாலும் யூஸ் பண்ணிக்கலாம், ஸ்டார்ட், ஸ்கிப், go to, anything you can use, but please remember it should be a meaningful name. Fine. Then one more thing, the label must not start with numerals. Numberla start பண்ணக்கூடாது, 1 loop 2 loop அப்படி எழுதக்கூடாது. Fine, it must start with a letter, that's mandatory. Then there should be no space in the label. For example, LOOP space 1 quota, that is meaningless. Correct? It should be a single word in a continuous sentence which must start with a character. Fine. So these things you have to note down. Similarly, loop 2, it is labeled to instruction 2. That means when this particular instruction got executed, your program flow will go to loop 2. That means from instruction 2 it will start execute. Fine. Can you people type it in the chat? In this particular picture, two of the instruction never going to be executed. In the particular program la rendu instruction எப்பவுமே execute ஆக போறதில்ல. Yes, very good, very good. Second class from the Sajis type. Yes, instruction 4 and 5, very good. Fine. See, so far jump அப்படினா meaning என்ன, unconditional jump அப்படினா meaning என்ன, it will go to the mentioned address. Fine. Actually, when we are writing the mnemonics, we will use label. Correct? This label is replaced by an address. For example, we will see a program now. Before that, JMP ADR, what will happen? The program execution jumps to the specified address. That means the specified address gets copied to the program counter register. Fine. So this is about the operation of jump instruction. Here, whenever it sees the unconditional jump instruction, it will jump to the particular address mentioned. Fine. Say for example, JMP 8005. The 16-bit address 8005 specified in the instruction gets copied to the content of program counter register. That's all. So the program எங்க இருந்து run ஆகும், 8005 memory location la என்ன instruction இருக்கோ, from there it will start running. Fine. So generally, while writing the ALP, the jump addresses are mentioned with label. Fine. Yes, clear? Can you people tell me how many bytes are required for jump instruction? How many bytes occupied by jump instruction? Yes, very good. 3 byte, 1 byte for opcode, JMP ka opcode. Okay, we will have an opcode. Then address is 16-bit, so we need 2 memory location. Totally 3 byte. What about the addressing mode? What about the addressing mode? See, எந்த அட்ரஸ்க்கு program jump ஆகணும் அப்படின்றதை எப்படி ஸ்பெசிஃபை பண்ணியிருக்கிறோம். What kind of addressing mode used here is direct addressing mode. See, எந்தெந்த instructionலாம், yes, very good, lovely, Danya, very good. Whichever instruction it is mentioned with an address, that indicates a direct addressing mode. Fine. Okay, now we can see an example. Consider this program. Okay, so in the program la வந்து பாத்தீங்கன்னா address column இருக்கு, opcode column I have skipped. Fine. label இருக்கு, then we are having mnemonics. Assuming the instructions are the instruction whose size are mentioned in the bracket. Instruction 1 2 byte அப்படின்னு சொல்றோம். அப்ப 8000 க்கு அப்புறம் 8002 like that we have a program. Fine. Here which instruction is a branch instruction in this given program? இங்க கொடுத்திருக்கிறதுல எந்த instruction வந்து branch instruction? On seeing you can see. அது மட்டும் தான் மென்ஷன் பண்ணிருக்கோம் obviously. In this given program you can see a branch instruction. What is that instruction? Yes, JMP. Very good. Okay. So பக்கத்துல நம்ம என்ன பண்ணிருக்கோம்? Loop அப்படினு லேபிள் பண்ணிருக்கோம். Where the label is available? In instruction 3. What about the address of the particular instruction, or in which address that particular instruction 3 is started? 8005. Correct? That means JMP ADR. That is the correct format. So instead of loop, what value it has to be replaced? When you are assembling the code, you have to assume the value of loop, the label loop, is assigned to the address 8005. Correct? So it should be like this. JMP 8005H. Correct? Okay, very good, very good, super. Fine. Now, before execution, okay, before execution, program counter enna value irukku parunga? 800B. That means we are assuming this particular instruction is going to be executed. Fine. So after execution, what will happen? In the particular instruction JMP 8005 execute anuchina, what will happen? After execution, what will happen? Yes? Yes. Program counter is copied with 8005. Very good. So program execution enga change aidichi. From instruction 6, it is jumping to again instruction 3. Forward jump or reverse jump? Forward பண்ணிருக்கோமா backward போயிருக்கா jump இங்க? Yes, reverse jump. Fine. So now what will happen? Instruction 3 போயாச்சு. இப்போ என்ன நடக்கும் சொல்ல முடியுமா? What will happen now? Instruction 3 execute ஆகும், கரெக்ட்டா? அதுக்கு அடுத்து எந்த instruction execute ஆகும்? After instruction 3, which instruction will get executed? Yes, instruction 6 ல இருந்து instruction 3 போயாச்சு, correct? So after executing instruction 3, then 4, then 5. Again after coming to 6th instruction, what will happen? Again it will go to instruction 3. That means, so it is operating in a loop structure. Again and again repeat idea. Fine. Can you people type it in the chat? What about the other instruction? Instruction 7, 8, halt. In the instruction execute ஆகிறதுக்கு ஏதாவது possibility இருக்கா? Is there any possibility? இந்த ப்ரோக்ராம் நம்ம ரன் பண்ணோம்னா instruction 7, 8 அப்புறம் 9th instruction halt execute ஆகுமா? Yes or no? No, definitely no. Okay, once it execute the 6th instruction, it will move to 3, 4, 5, 6. Again move to 3, 4, 5, 6, 3, 4, 5, 6. That's why I named the label like loop. Correct? Whether this loop is infinite or finite. 4 தடவை ரன் ஆகும், 5 தடவை ரன் ஆகும் சொல்ல முடியுமா? How many times the loop will run? Yes, infinite loop. Clear? Fine. See, this kind of things you have to know. So இதே இது C programல என்ன எழுதிருப்பீங்க? While of 1 அப்படினு எழுதுவோம். கரெக்ட்டா? While of 1 means what? While of 1 அப்படினா மீனிங் என்ன? Always true. Very good. That means always the loop is going to run. The same here also. Clear? Fine. Again, so நம்ம முன்னாடி பார்த்தது என்னது? Reverse jump. Now we will see like this. Instruction 1 execute ஆகுது, instruction 2 execute ஆகுது. Fine. Now we are considering JMP skip instruction. That means instruction 3. correct? I think here instead of instruction 6 it is mentioned as 2, sorry. So it must be 6, I'm sorry. Yes, now it's correct. Okay, so now the skip refers to the address 800B, that means it is jumping to instruction 6, correct? So now what will happen before execution? Before executing the jump instruction, it will be like this. After execution, what will happen? What will happen? After executing JMP 800B, what will happen? Yes, program counter copied with the particular address 800B. So now it comes to the instruction 6, correct? Fine. Now what will happen? After executing 6th instruction, in the instruction execute our next. Yes? Any idea? See, 3rd instruction and 6th instruction jump aidichu, correct? Next 7th instruction, next 8th instruction, then finally halt instruction, correct? So here it skipped the in between memory location. Okay, see, label kudukrappa konjam nam enna pannalam, we can give a meaningful naming. Fine. See, rendu vidhamana jump possible, ada சொல்றதுக்கு தான் இந்த ரெண்டு ஸ்லைட்ஸ் நம்ம யூஸ் பண்ணிருக்கோம். Fine. Both forward and reverse jump, both are allowed, correct? That means you can jump anywhere. Totally we are having 64 KB memory location. Anywhere you can jump. எந்த ஒரு memory location வேணாலும் நீங்க jump பண்ணலாம். Fine. So that's all about the jump instruction. Okay. Fine. Now we'll go with the call instruction. So in the previous session I have we have stopped here. Fine. So it's a main program and here we have a sub program, correct? This we call it a subroutine. Okay. So this we are considering it as a main program. Fine. Can you people remember? In the case of jump instruction, whatever the address you are mentioning, it is copied to the program counter. That's all. Kanna mudittu and eduthu jump pannidum, avladha. Correct? The program execution control transfers from the executing instruction address to that specified address. That's all. What about in the case of call? Call and return, you have to remember both are having a relation, correct? Fine. So if call panna enoda subprogram oda end la na enna pandren, return use pandren, correct? So adu first vishayam nama nyabagam vechukonum. Fine. What about the most important thing of call instruction? The last class itself I have explained you. On seeing this diagram, you can tell. Call instruction execute ஆகிறப்ப நமக்கு என்ன ஆகுது? Program counter holds the address of next instruction. Okay. Yes. So that is stored into the stack memory. Then நம்ம கொடுத்த address program counter load ஆகுது. So it will execute the subprogram. At the end, we have a return instruction. Fine. Here we didn't mention any address. That means whatever the address stored on the top of the stack, it is popped again to program counter, correct? So it will continue the next instruction in the main program. Okay. So idu puriyalanalo paravalla, we can have an example here. Consider this example. Consider this example. Okay. We are assuming program counter is having 8002 now. That means this particular instruction has to be fetched, correct? The call instruction namakku fetch aga poduna. Fine. After fetching the call instruction, what will be the content of program counter? Can you people type it in the chat? Call instruction endha address la irukku? 8002. It is a 3-byte instruction. So what about the value of program counter after fetching the call instruction? Any idea? No, you kindly listen my word. I didn't say after executing call instruction. What my question is, after fetching the call instruction. And the call instruction நம்ம fetch பண்ணி எடுத்தாச்சுன்னு வெச்சுக்கலாம். CPU fetch பண்ணி எடுத்தாச்சு. Correct? So automatically program counter எதை point பண்ணிட்டு இருக்கும் first? where the program counter points. See, again, listen my wording carefully. நான் சொல்ற வார்த்தையை கவனமா கவனிங்க. Call instruction execute ஆகல. The CPU just fetches the call instruction. That means it doesn't indicate it executed the call instruction. என்ன பண்ணணும்ன்றத எடுத்து வச்சிருக்கு, இன்னும் எக்ஸிக்யூட் பண்ணல. கரெக்டா? சோ அப்ப அடுத்த இன்ஸ்ட்ரக்ஷன் எந்த அட்ரஸ்ல இருக்குது? Yes, very good Danya, 8005. That means after fetching the call instruction, the program counter points to instruction 3. Correct? Now, if a call instruction execute ஆக போகுதுன்னு வச்சுக்கோ. Fine. While executing the call instruction, what CPU has to do? போன டயக்ராம் நம்ம பார்த்ததை இங்க ரிலேட் பண்ணலாம். Return address. That means the next instruction address, instruction 3, அதனுடைய address எங்க போய் ஸ்டோர் ஆகும்? Where it has to be stored? Program counter? No. See, what I am asking is, now you assume 8002 is available in program counter. That means it is fetching the call instruction. Correct? Call 8100 3 byte instruction fetch பண்ணுது. After fetching the call instruction, automatically program counter points to the next instruction. Okay, now the call instruction going to be executed. Call instruction execute ஆக போகுது அப்படின்னா மீனிங் என்ன? Before it is transferring the control to the specified address, it has to store the next instruction address to the stack memory. Correct? So next instruction address யார்கிட்ட இருக்கு? program counter இருக்கு. அது எங்க போய் ஸ்டோர் ஆகணும்? stack memory ல ஸ்டோர் ஆகணும். Now carefully listen. Stack pointer is having 8505. That means it is pointing to this filled location. Correct? That is first point. What value has to be put into the stack now? The next instruction address 8005. It is available in the program counter. That means 8005 has to push into the stack. Correct? Fine. Now 8505 is already having some data. Correct? Up in the address order, higher byte ulla push aganumna first stack pointer enna aganum? It has to point to the upper memory location. So stack pointer first enna aganum? To push the program counter content into the stack memory, first stack pointer has to be decremented by 1. Correct? So stack pointer 1 decrement ஆயிடுச்சு. 8505 ல என்ன இருக்கு? 8504. Correct? Now it is pointing to the empty location. Now higher byte of the program counter register, that means 80, is pushed into the stack. Now you people tell me again what has to do for storing the lower byte? Higher byte stack la poi store ஆயிடுச்சு. கரெக்ட்டா? Lower byte store ஆகணும்னா என்ன ஆகணும்? Again what has to happen? Again decrement by 1. Fine. So 8504 stack pointer value becomes 8503. So it points to the empty location. Now 05 will get stored. That's all about the address storage. Next instruction address என்னது actually 8005. அதனுடைய address எங்க ஸ்டோர் ஆயிடுச்சு? stackல ஸ்டோர் ஆயிடுச்சு. Now what about the address 8100? இது எங்க போகணும்? Where this address has to be stored so that my program start executing from that address? Yes, program counter. Very good. Correct? நல்லா கவனிச்சீங்கன்னா தெரியும். call instruction execute ஆகறப்ப எப்பவுமே என்ன ஆகுது? The next instruction address or the return address, fine, it is holded by the program counter. It gets stored into the stack. நல்லா கவனிக்கணும். call instruction execute ஆகறப்ப the next instruction address available in the program counter gets stored into the stack. Correct? So 2 bytes அப்படின்றதுனால stack pointer என்ன ஆகுது? First decrement by 1, storing the higher byte, again decrementing by 1, storing the lower byte. Correct? So here in 8085 we are having the descending stack. Okay, it points to the filled byte. Correct? So கடைசியா எனக்கு stack pointer point பண்ணிட்டு இருக்குது என்னது? Last inserted data, not the empty location. Please understand that. Fine. Now so 8100 வந்துருச்சா program counterல? இப்போ program என்ன ஆகும்? In the second program, I mean in the sub program, மேல உள்ளது main routine. I forgot to mention it. Sorry for that. So மேல உள்ளது என்னது? Main routine. கீழ உள்ளது என்ன அப்படினு பாத்தீங்கன்னா it's a subroutine. Correct? So now the subroutine address 8100 is loaded into the program counter. So now the program got executing from 8100. Correct? Instruction 1, instruction 2, instruction 3. Correct? கடைசியா எந்த instruction execute ஆகும்? What about the last instruction executed in the subroutine? Which instruction? Yes, very good. So 8107 vandachu. Correct? Now program counter is pointing to 8107. Correct? Now you assume this particular return instruction is fetched. Fine? So in the instruction fetch aidichi. After execution, can you people tell me whether we have mentioned any address, return address in the return instruction? Call pandrappa we have mentioned the address. Correct? Now whether we mention any return address? No. Then how CPU knows? Then how CPU know this is the return address? Whenever the return instruction is getting executed, the top 2 bytes available in the stack memory are get into the program counter. That's all. Return na meaning enna? Stack la kadasiya potta 2 byte program counter la poi load agum. Lower byte first, higher byte next. Push பண்றப்ப எப்படி ஸ்டோர் ஆனச்சு? Higher byte then lower byte. Pop பண்றப்ப lower byte, higher byte. Correct? Yes. Now return instruction என்ன நடக்கணும்? Can you people say? Return instruction execute ஆகுறப்ப என்ன நடக்கும்? Can you people say? இப்ப top of the stack la என்ன value இருக்கு? 05. That is the lower byte of the return address. Correct? So 05 எங்க போய் ஸ்டோர் ஆகணும்? Yes, program counter க்கு 8005 போகும். எப்படி போகும்? நல்லா கவனிக்கணும். Top of the stack it is having 05. It is moving to program counter 05. Then decrement by 1. Again 80. Decrement by 1. Fine. Now stack pointer points to the initial memory location. Please understand one thing. Generally, நம்ம push அப்படினா inserting data அப்படினு படிச்சிருக்கோம். Pop அப்படினா removing data அப்படினு படிச்சிருக்கோம். Correct? That means we are getting back the data from stack. Whatever the content we pushed. Correct? But physically, the content will be available that it is meaningless. Now the top of the stack is 8505. Correct? So when you again push பண்ணீங்கன்னா data வந்து இதுல overwrite ஆயிடும். When you are popping the data, actually delete ஆகாது. Stack pointer refers to the top of the stack always. அதை ஞாபகம் வச்சிருந்தா போதும். It doesn't mean நம்ம pop பண்றப்ப data வந்து 0 ஆயிடுமா? It's not like that. நம்ம என்ன push பண்ணோமோ அது மேல இருக்கும். Correct? But now currently top of the stack is containing the actual data. Original என்ன இருந்துச்சு? First XX. It is pointing to that location. Clear? So stack பொறுத்த வரைக்கும் clear-ஆ ஒரு விஷயம் தெரிஞ்சுக்கோங்க. When you are inserting data, it will be overwritten on the upper memory locations. Fine? நம்ம remove பண்றப்ப என்ன ஆகும்? Actually delete ஆகாது. Physically it won't get deleted. But it is not considered as a stack element. Stack portion la irukadu. Clear? The last element what we have inserted into the stack, it defines the area of the stack. Clear? Okay. So now program counter is copied with 8005. So enna aidichi? It is returning to where? It is returning to where? That's very important question. Call பண்ணப்ப இந்த sub program க்கு வந்துச்சு. At the end return போட்டுறோம். Return பண்ணோனே எங்க இருந்து program execution start ஆகுது? Whether it is again starting from the beginning of the main program? Yes, very good Dixon. It is continuing from instruction 3. What it means? What it means? Main program la instruction 3 execute ஆகுது. What it means? Reversed. It's not like that. See, main program la call instruction வந்ததுக்கு அப்புறம் நமக்கு என்ன ஆகுது? Program control is transferred to the sub program. Correct? Subroutine க்கு போயாச்சு. At the end of the sub program, if we use the return, what is happening? Returning to the main program and executing and continue the main program execution. Correct? எங்க விட்டுச்சோ அதில இருந்து கண்டினியூ பண்ணுது. கரெக்ட்டா இல்லையா? instruction 2 தான் கடைசியா execute ஆனது. அப்ப next instruction in the main program is instruction 3. That means whenever you use call instruction, it is going to the particular address. Before that, the next instruction address is pushed into the stack. Fine. In the particular subroutine, if we use the return instruction at the end, it will return to the main program by popping out the top of the stack values to the program counter. Correct? See, நான் அடுத்து எங்க கண்டினியூ பண்ணனும், மெயின் ப்ரோக்ராம்ல எதை கண்டினியூ பண்ணனும்ன்ற அட்ரஸை ஸ்டாக்ல புஷ் பண்ணியாச்சு. Fine. Then it is going to the subprogram. At the end of the subprogram, return instruction use பண்ணிருந்தால் definitely we must use return at the end of the subroutine. Fine. So return use பண்றப்ப என்ன ஆகுது, டாப் ஆஃப் த ஸ்டாக்ல தான் நம்ம புஷ் பண்ணிருந்தோம். எதை புஷ் பண்ணிருந்தோம், return address. Again it is moving to program counter, so it continue executing the main program. Fine. Now you people can tell the difference between jump and call instruction. Jump எங்க யூஸ் பண்ணலாம், call எங்க யூஸ் பண்ணலாம்? Any idea? Any idea? My next question, what happen if I use jump and return instruction? இங்க நான் வந்து jump 8100 போட்டுட்டு இங்க return யூஸ் பண்ணியிருந்தா என்ன நடக்கும்? Any idea? சரி, நான் கேட்கிற கேள்வி புரியுதாப்பா? Yes, unpredictable execution takes place. Very good, Shivakumar. Jump யூஸ் பண்ணிட்டு நம்ம return யூஸ் பண்ணா next instruction at stackல போய் கண்டிப்பா ஸ்டோர் ஆயிருக்காது. கரெக்ட்டா? சோ இப்போ என்ன இருக்கும், டாப் ஆஃப் த ஸ்டாக்ல some unpredictable value, ஏதோ ரெண்டு வேல்யூ இருக்கும், 2 bytes will be there. Correct? That will get loaded into the program counter. That means jump யூஸ் பண்ணிட்டு அந்த ப்ரோக்ராமோட எண்ட்ல return யூஸ் பண்ணா it is meaningless. Correct? சோ இப்போ jump எங்க யூஸ் பண்ணலாம், call எங்க யூஸ் பண்ணலாம்? Any idea? Jump during infinite looping, it's not like that, Danya. Jump infinite looping மட்டும் அப்படினு சொல்ல முடியாது. Unconditional jump we can use. Fine. Jumpல ரெண்டு டைப் இருக்கு. Fine. அல்ல reverse jump அப்படினு போறப்ப you can have a unconditional jump யூஸ் பண்ணீங்கன்னா infinite looping இருக்கும். Fine. Generally jump is used in the single program. ஒரு main programக்குள்ள நான் எங்க வேணா jump பண்ணனும் அப்படினா I can go for jump operation. Fine. If I want to call some other program, நான் தனியா ஒரு program main program வச்சிருக்கேன், I have some other program called subroutine, subroutine 1, subroutine 2, subroutine 3. These are different functions. Okay, இந்த particular subroutineல எதுக்கு போறோம் அப்படினு பார்த்தோம்னா, when I am using a repeated operation in my main program again and again. Correct? ஒரு particular operation எனக்கு main programல நிறைய இடத்துல தேவைப்படுதுன்னா ஒவ்வொரு இடத்துலயும் அந்த ஆபரேஷனுக்கு ப்ரோக்ராம் எழுதணும்னா it occupies more space. To avoid that, we are having a subroutine. Okay, whenever you want to perform that particular operation, you can call that subroutine. Correct? So call instruction is used to call the subroutine, whereas jump instruction can be used in a single program wherever you want to jump. That's all. Clear? Is it clear? Jump instruction யூஸ் பண்ணி நான் இன்னொரு ப்ரோக்ராமை கால் பண்ண என்ன ஆகும், ஐ மீன் இன்னொரு ப்ரோக்ராமை நான் எக்ஸிக்யூட் பண்ணணும்னா என்ன பண்ணணும், இங்க நீங்க ஜம்ப் போட்டீங்கன்னா எண்ட்லயும் நீங்க என்ன பண்ணணும், ஜம்ப் டு தி நெக்ஸ்ட் இன்ஸ்ட்ரக்ஷன் அட்ரஸ். மேனுவலி யூ ஹேவ் டு ரைட், யூ ஹேவ் டு கால்குலேட் எவ்ரிதிங். தட் இஸ் மீனிங்லெஸ். தட்ஸ் வை வி ஆர் ஹேவிங் கால் இன்ஸ்ட்ரக்ஷன். ஃபைன். ஜம்ப் வித்தின் அ ப்ரோக்ராம், கால் அண்ட் அனதர் ப்ரோக்ராம், தட் வி கால் இட் அ சப்ரூட்டீன். தட்ஸ் ஆல். அப்ப நம்ம பிக்டோரியலா இங்க பார்த்ததை இங்க நம்ம என்ன இருக்கு, வேர்டிங்கா சொல்லியிருக்கோம். The next instruction address available in the program counter is pushed into the stack, and then the address ADR of the subroutine to be placed into the program counter. Fine. So அதுக்கு நடந்த ஸ்டெப்ஸ் தான் இங்க நம்ம பிக்டோரியலா பாக்குறது. கரெக்ட்? வேர்டிங்ஸ்ல பாக்குறது. ஸ்டாக் பாயிண்டர் ஒன்னு டிக்ரிமெண்ட் ஆகும், then program counter higher byte stored into the content of the memory pointed by stack pointer. Please note down the word content of the memory pointed by stack pointer. That's why we are having double bracket. Fine. Again, stack pointer get decremented by 1. In that particular memory location, lower byte will get stored. That's all about the call instruction. Kindly note down this. You screenshot எடுத்துக்கோங்க. We will move to next slide. So this is what call instruction. Call address அப்படின்னு சொன்னோம்னா இதான் நடக்கும். Fine. One more step I missed now. இன்னும் ஒரே ஒரு ஸ்டெப் இதுல மிஸ் ஆயிருக்கு. என்னன்னு சொல்ல முடியுமா? இந்த கன்வென்ஷன்ல ஒரே ஒரு ஸ்டெப் நான் எழுதல இன்னும். என்னன்னு சொல்ல முடியுமா? I didn't display. Can you people say? Stack pointer ஒன்னு decrement ஆச்சு. Higher byte of program counter store ஆனிச்சு அந்த memory locationல. Again stack point. Yes, very good Logus Nega. Very good. Very good. Very good. Super. Lovely and Logus Nega. I really appreciate you two people. Fine. So call instruction சொன்னோம்னா the first 4 step என்ன நடந்துச்சு? Yes, very good Sajis. Classroom 2 Sajisum type பண்ணிருக்காரு. But you missed the bracket Sajis. Content of program counter க்கு the address copy ஆகும். Fine. Okay. Fine. So the first 4 steps, it is storing the program counter value to the top of the stack. Then the given address is loaded into the program counter. That's all. Fine. Similarly, return instruction. The program execution gets returned from subroutine to main program. Correct? என்னோட program execution subroutine ஓட endல தான் கண்டிப்பா return யூஸ் பண்ணிருப்போம். Fine. So it is going to return to the main routine. It is going to return to the main routine. Here we didn't mention any return address. So where the return address must be? Where the return address will be? கண்டிப்பா கால் யூஸ் பண்ணி தான் நம்ம சப்ரூட்டினுக்கு வந்திருப்போம். எஸ், வெரி குட் சிவகுமார், வெரி குட். ஸ்டாக் மெமரி, ஸ்டாக் மெமரியில எங்க இருக்கும்? டாப் ஆஃப் தி ஸ்டாக். டாப் ஆஃப் தி ஸ்டாக்ல தான் லோவர் பைட் அண்ட் ஹையர் பைட் ஃபாலோட் பை ஹையர் பைட் வில் பி தேர். கரெக்ட்? சோ இதுக்கு கன்வென்ஷன் நீங்களே எழுத முடியுமா? எஸ், yes. Can you people write the convention for return instruction? First, stack pointer point பண்ற memory location உள்ள content program counter ஓட lower byte க்கு போகும். கரெக்ட்டா? The content of memory pointed by stack pointer is popped to lower byte of PC. Correct? அதுக்கப்புறம் stack pointer must get incremented by 1. That means it popped the data means it has to point to the field location again. Convention எழுதலாமா? Or else I will display it. Okay, ரெண்டு லைன் நான் காமிக்கிறேன், அடுத்த ரெண்டு லைன் நீங்க ட்ரை பண்ணுங்க. The content of the memory pointed by stack pointer is copied to lower byte, then stack pointer will get incremented by 1. Correct? Data எடுத்தா increment ஆகும், insert பண்ணா decrement ஆகும். That we have already studied. What about the next thing? Next 2 lines என்ன வரும்? சொல்ல முடியுமா? The next 2 lines. Now the field location is pointed by the stack pointer again. That content, yes, very good Sajis, very good. Classroom 2 la Sajis type பண்ணிருக்காரு, very good. First lower byte எடுத்து program counter lower byte la store பண்ணியாச்சு, top of the stack. Now it is pointing to the below memory location. So stack pointer gets incremented by 1. Yes, very good. Very good, Lovely. Very good, Shivkumar. Very good. But yes, P bracket la varano +1. Okay. அது மட்டும் கரெக்ட் பண்ணிக்கோங்க. இப்ப பிராக்கெட்ல SP +1 மீனிங் என்ன? Stack pointer +1 அப்படின்னு மீனிங் ஆயிடும். Correct? So that's all about the return instruction. So we all very well know about jump instruction, call instruction and return instruction. We can assume like that. Yes? Is it clear? Jump, call, return. 3 instruction புரிஞ்சுதா எல்லாருக்குமே? Yes. Very good. Whatever we have discussed this unconditional jump, unconditional call, unconditional return. In the instruction வந்தாலே இந்த ஆபரேஷன் நடக்கணும். Correct? Now we can have conditional instruction. Before that we have one more instruction, PCHL. So the program execution is branched to the address pointed by HL register pair. HL register pair la enna address irukko and the particular address ku program execution transfer ஆயிடும். Say for example will be like this. Before execution எப்படி இருக்கு, after execution என்ன நடக்கும்? After execution, what about the content of program counter? HL register pair la enna value இருக்கோ அது எங்க போய் ஸ்டோர் ஆக போகுது? It is copied to program counter. Fine. So after execution, what will be the value of program counter? before execution இப்படி இருக்கு. Yes, program counter content will be 9000H. Fine. Yes. See, இந்த விஷயத்தை நல்லா நோட் பண்ணி வச்சுக்கோங்க. Kindly note down what I am saying now. Fine. It will be useful for you in later purpose. Okay. உங்களுடைய ட்ரெய்னர் கிட், கரெக்ட்? லேப்ல நம்ம யூஸ் பண்ண ட்ரெய்னர் கிட் இருக்கு இல்லையா, 8085 பேஸ்டு மைக்ரோ கம்ப்யூட்டர் ட்ரெய்னர் கிட். ஃபைன். இந்த ட்ரெய்னர் கிட் the monitor program is running, correct? So அதை பேஸ் பண்ணி தான் நீங்க கீ பிரஸ் பண்றப்ப ஒவ்வொரு மெமரி லொகேஷன்ல வேல்யூலாம் ஸ்டோர் பண்ணிட்டே வரணும், கரெக்டா? ஃபைன். Now clearly underline what I am saying. When you are executing your program, நீங்க உங்க ப்ரோக்ராம ரன் பண்ற அந்த மொமெண்ட்ல என்ன நடக்கும் அப்படின்னா, கோன்ற கீ பிரஸ் பண்ணுவீங்க, கரெக்டா? go address execute, கரெக்டா? go address execute. This is the sequence we are using to execute the program in the particular trainer kit, correct? அப்ப go அப்படின்னு கொடுத்ததுக்கு அப்புறம் the CPU is asking for a 16-bit address, correct? Say for example go 8000 அப்படின்னு கொடுத்தனா இந்த 8000 வேல்யூ எங்க போய் ஸ்டோர் ஆகும்? HL ல தான் ஸ்டோர் ஆகும். HL register pairல ஸ்டோர் ஆகும். go, it is waiting for a data, waiting for a address. After we are inputting the 4 digits, that particular address is storing into the HL register pair. அப்ப execute key press பண்றப்ப என்ன நடக்கும்? When you are pressing the execute key, what will happen? PCHL instruction will run. That's all. Correct? So automatically monitor program controller in the kit நம்மளோட program control க்கு வந்துரும். Correct? So again monitor program control க்கு போறதுக்கு தான் நம்ம என்ன பண்றோம்? Reset key press பண்றோம். Clear? Yes. From one program execution through hardware, you can transfer the control to some other memory location with this kind of instruction. Correct? So program counter value modify பண்றதுக்கு இருக்கிற ஒரே possibility PCHL instruction. Fine. Otherwise நீங்க என்ன பண்ணணும்? Jump or call instruction தான் யூஸ் பண்ணணும். Fine. It is equivalent to jump instruction, but address யார்கிட்ட இருக்கும்? HL register pair is having the address. Correct? Is it clear to all of you? Yes or no? PCHL is equivalent to jump instruction, but address எங்க இருக்கும்? HL register pairல இருக்கும். That's it. Fine. So RST-N. So இது நம்ம எல்லாருக்குமே தெரியும். Fine. RST-0 to RST-7 வரைக்கும் இருக்கலாம். Fine. This particular instruction is equivalent to call. It is called as 1 byte call instruction. You can see it as 1 byte call instruction. In the particular instruction நம்ம என்ன மீன் பண்றோம்? It is equivalent to call instruction, but address எப்படி ஸ்பெசிஃபை பண்ணிருக்கோம்னு பார்க்கலாம். program counterல என்ன வேல்யூ லோட் ஆகுது? Kindly observe this last point in the convention. Program counter is copied with what? N star 8, N into 8 in hexadecimal. Please remember in hexadecimal. Say for example RST4 you consider. RST4 consider பண்ணீங்கன்னா what about the N value? 4. 4 into 8 is what? 4 into 8 என்ன வரும்பா decimal ல? What is the value? 32. Just convert it to hexadecimal. Hexadecimal ல convert பண்ணா என்ன வரும்? 32 hexadecimal ல convert பண்ணா என்ன வரும்? I will type it in the chat. Definitely it must be 20H. Correct? Yes or no? See, I am considering RST4. RST4 அப்படின்னா மீனிங் என்ன? எந்த அட்ரஸ்க்கு இது கால் பண்ணணும் ப்ரோக்ராம்? 4 into 8. That means 32 in decimal. In hexadecimal it is 20H. But address is always 16-bit. So 8 bits, 8 zeros will be added before the number. That means 0020 is the restart address. So restart address எதை டிபெண்ட் பண்ணியிருக்கும்? The value of N. RST0, RST1, RST2, RST3 up to RST7 we are having. Fine. So that's all about the RST instruction. Is it clear? Call பண்றதுக்கு முன்னாடி என்ன நடக்கணும்? So this we call it as vector address or restart address. So this is the vector addressing. So that means whenever this particular software interrupts RSC0 to RSC7 is getting executed, the call address is predefined, that is fixed with the value of n. Each n is having, that means each number is having its own vector address or restart address. Fine. So before loading that particular vector address into program counter, the program counter value is copied to or pushed into the stack. That means return address save ஆயிட்டு தான் நம்ம கொடுக்கிற restart address load ஆகும். It is equivalent to call. That's why it is called as one byte call instruction. Fine. Actually, this is a software interrupt. Fine. When software interrupt is introduced, the next instruction address gets stored into the stack memory. Then the vector address is getting loaded into the program counter. That's all. That's all about the RSTN instruction. Okay. So இது வரைக்கும் நம்ம பார்த்தது எல்லாமே வந்து பாத்தீங்கன்னா unconditional jump, call, return, then PCHL, then RSTN instruction. Fine. Now we are going to discuss about the conditional branch instruction. Fine. So conditional branch instruction examine the condition of the particular flag bit. ஒவ்வொரு conditional instructionலயும் ஏதோ ஒரு flag bit நம்ம டெஸ்ட் பண்ண போறோம். If the condition is true, then it will jump, then it will call, then it will return. Otherwise, it will skip the particular instruction. Please remember that. So the condition that may be specified are as follows. இதெல்லாம் இருக்கலாம். Fine. N is Z, no zero. Z. See, in the prefix, that means in the suffix எல்லாம் நோட் பண்ணி வெச்சுக்கோங்க. J க்கு பக்கத்துல என்ன வரலாம்? N is Z. JX அப்படினு போட்டோம் இல்லையா? X can be replaced by this value. J is Z, J is Z, JNC, JC, JPO, JPE, JP, JM. These are the conditional jump instruction. இதே call instruction சொன்னா என்ன வரும்? CN is Z, C is Z, that we will see in the next slide. Fine. So out of the 5 flags, only 4 flag bit condition are tested. Which one is skipped here? எந்த ஒரு particular flag ஓட status check பண்ண முடியாது through condition பார்த்தே சொல்லலாம். Which one of the flag bit is missed here? Zero flag test பண்ணலாம், carry flag test பண்ணலாம், parity flag test பண்ணலாம், sign flag we can test. Very good. Auxiliary carry flag cannot be tested. Correct? So அதுக்கு டெஸ்ட் பண்றதுக்கு conditional instruction கிடையாது. Because why auxiliary carry is used? ஒரே ஒரு இடத்துல மட்டும் நம்ம அதை சொல்லியிருக்கோம். ஜெனரலா auxiliary carry எங்க யூஸ் ஆகுது? While performing BCD addition. ஒரே ஒரு இடத்துல மட்டும் நம்ம சொல்லியிருக்கோம். auxiliary carry வந்து எங்க யூஸ் ஆகும் அப்படின்னு பாத்தீங்கன்னா BCD additionல மட்டும் தான் யூஸ் ஆகும். Clear? Fine. So all other flags can be tested except auxiliary carry. Correct? நல்லா கவனிங்க. Zero flagல zero value இருந்துச்சுன்னா மீனிங் என்ன? No zero. That means result of the previous ALU operation is non-zero. Correct? If it is zero, zero flag set ஆகும். அதனாலதான் இப்படி போட்டுக்கணும். No zero, zero. No carry, carry. Parity odd அப்படின்னா மீனிங் என்ன? Parity bit 0 இருக்கும். Parity even அப்படின்னா parity bit 1. Plus, if the previous ALU operation result in positive number, plus. Correct? That means sign flag 0 இருக்கும். Minus அப்படின்னா sign flag 1 இருக்கும். That's all. You can relate this table. நல்லா கவனிங்க. Conditional branch instruction. Jumpனா என்ன வரும்? JX. X உள்ள இடத்துல என்ன ரீப்ளேஸ் பண்ணிருக்கோம் பாருங்க. If carry அப்படின்னா மீனிங் என்ன? C equal to 1, JC, JNC, JZ, JNZ. ஒவ்வொரு flag-ஓட கண்டிஷனையும் டெஸ்ட் பண்ணிட்டு அதுக்கப்புறம் என்ன பண்றோம்? Jump. If the condition is true, then it jump to the particular address, or else it will skip the jump instruction. அந்த instruction-ஐ skip பண்ணிட்டு next instruction போயிடும். Such instruction we call it as conditional instruction. So அதுல jump, call, return ஆகும். Fine. Kindly take a screenshot. We'll move to next slide. I hope everyone understand this. Yes? Okay sir, நீங்க C program எழுதுறப்ப என்ன பண்ணுவீங்க? ஒரு for loop ஓட syntax யாராவது எழுத முடியுமா? டைப் பண்ண முடியுமா chatல? Can anyone type the for loop syntax in the chat? Yes, anyone? Anyone type the for loop syntax? C ல நீங்க எழுதுவீங்க இல்லையா for loop? Yes. For initialize condition increment or decrement. Correct? So இப்போ மீனிங் என்ன அப்படின்னு பாத்தீங்கன்னா இந்த மாதிரி for loop நான் வந்து அசம்பிளி லாங்குவேஜ்ல எழுதுறப்ப I can have a count in one register. ஒரு ரெஜிஸ்டர்ல count வேல்யூ போட்டு நான் என்ன பண்ணுவேன்? Decrement that register. அந்த ரெஜிஸ்டரோட வேல்யூ இப்போ 0 இல்லைன்னா again continue. மீனிங் என்ன? What instruction I have to use? If it is non-zero, continue. So what instruction I have to use? Jump instruction I have to use. இந்த டேபிளை பார்த்தே சொல்லலாம். Jump no zero. எந்த instruction நான் யூஸ் பண்றேன்? JNC na jump no carry. Sivakumar, JNZ is the correct answer. Okay, JNZ we have to use. Okay, probably the coming lab session. Okay, Friday aniki namak lab session irukku illaya. In that lab session, we are going to use the branch instructions. We are going to start using the branch instructions. Fine. I hope everyone understand the branch group of instruction. Yes. Shall I proceed to next slide? Yes, fine. Difference between jump and call instruction. Already I have told you. Program counter is not stored in the stack memory before getting into the address specified in the instruction. Correct? Jump la vandu next instruction address stack la store agadu, whereas call enna program counter content is stored in the stack memory, then the address will be loaded into the program counter. Correct? Similarly, after jump instruction, using return instruction is meaningless. Jump பண்ணி ஒரு ப்ரோக்ராம்க்கு போயிட்டு அதோட எண்டில் ரிட்டர்ன் யூஸ் பண்ணா that is meaningless. Correct? Return எப்போ யூஸ் பண்ணணும்? Without call operation, return cannot be done. Fine? So this you have to understand. After call instruction, return instruction need to be written at the end of the subroutine. Call instruction நம்ம execute பண்ணா ஒரு subroutine போகும். Return instruction must be used at the end of the subroutine so that it is meaningful. Correct? Yes. So jump generally எங்க யூஸ் பண்றோம்? Within a single program, anywhere you can jump. Okay. Call instruction where we have to use? When you want to call a particular subroutine, you can use call instruction. That's all. So the last group of instruction is stack, IO and machine control instruction. Okay. Stack operation related instruction எல்லாமே stack instruction சொல்லுவோம். IO, that means input output device கூட communicate பண்றதுக்கு we have two instruction under IO instruction. Then we have many machine control instruction. Fine. The machine control instruction la one of the instruction we are using in our lab session 1 and 2. Experiment 1, experiment 2, we have used one of the machine control instruction. Can you people judge it? Identify it? Already experiment 1, 2 இதெல்லாம் நம்ம சொல்லி கொடுத்தப்ப one of the machine control instruction we have used always at the end of the program. Yes, very good Shivakumar. Very good, very good. HLT is a kind of machine control instruction. Fine. It won't transfer any data, or it won't do any arithmetic or logical operation, or it won't branch to any other location. It simply do some mission level control. Okay, so it will just stop the program execution by holding the program counter value idle. Okay, program counter value next increment another எனக்கு என்ன ஆகும்? Next instruction point பண்ணும். Fine. So it will freeze the program counter value. That's all. Fine. So stack instruction la என்னென்னலாம் இருக்குன்னு பார்க்கலாம். The stack instructions include push or pop operation to insert or delete the data on the stack memory pointed by stack pointer. Correct? So no flags get affected while executing this instruction except for pop PSW instruction. Pop PSW instruction will affect the flag content. Why? Why? Any idea? Actually, எந்த flag affect ஆகாது stack related operation perform பண்றப்ப except pop PSW instruction. Why? What is PSW? What is PSW? PSW indicate the combination of which two registers? Any idea? Yes, accumulator and flag. Correct? In that PSW word format, which one is lower byte, which one is higher byte? And the 16-bit word format la edu lower byte of the PSW irukum, edu higher byte of the PSW irukum. Flag content, accumulator content. Yes, flag content is lower byte, accumulator content is higher byte. Correct? Fine. Fine, very good. So for pop PSW na enna nadakum? Stack la ulla top of the two data is popped to accumulator and flag. Correct? So definitely flag content will get modified. Clear? Fine. See, this kind of question, it's challenging thing. உங்களோட ப்ரோக்ராம் ஒன்று கொடுத்துட்டு இதில் எனக்கு ஃபிளாக் எப்படி அஃபெக்ட் ஆகும்னு கேட்கலாம். இந்த மாதிரி பர்டிகுலர் ப்ரோக்ராம் கொடுத்துட்டு pop PSW means top of the 2 bytes available in the stack is copied to the accumulator and flag register. Okay, so that flag content will get affected. So that's why pop PSW affect the flag content அப்படின்னு சொல்லியிருக்கோம். Fine. என்னென்ன stack operation இருக்கு அப்படின்னு பார்த்தீங்கன்னா push pop PUSH, that's all. Okay, followed by the name of the register pair or PSW. புஷ்க்கு பக்கத்துல என்ன வரலாம்? புஷ்க்கு பக்கத்துல என்னென்ன ரெஜிஸ்டர் பேர்ல நம்ம மென்ஷன் பண்ணலாம்? புஷ்க்கு பக்கத்துல என்னென்னலாம் வரலாம்ப்பா? புஷ் அப்படின்னு சொன்னோம்னா ரெஜிஸ்டர் பேர் கண்டென்ட் has to be pushed into the stack. Pop அப்படின்னா மீனிங் என்ன? Pop the data from the stack to a register pair. So the stack operation in 8085 is always 2 byte operation. Don't forget it. The stack operation in 8085 is always 2 byte. Then SPHL, like PCHL எப்படி நம்ம யூஸ் பண்றோமோ அதே மாதிரி SPHL instruction is there. That means HL register pair content is copied to stack pointer. That's all. Okay, so this 3 instruction we call it as stack instruction. That's all. Moone stack instruction. Okay, we'll go one by one. The stack pointer register can be initialized. Stack pointer register initialize பண்றதுக்கு இந்த particular instruction நீங்க யூஸ் பண்ணிக்கலாம். Fine. So this is a type of data transfer group of instruction. Correct? So LXI, SP, any value you can put, 16-bit value you can put. That will put a 16-bit content, 16-bit value into the content of stack pointer. By that means you can initialize the stack pointer. Fine. The other way is HL register pair la or value போட்டுட்டு SPHL எழுதியும் you can initialize the stack pointer. There are 2 ways to initialize the stack pointer. Direct value நீங்க கொடுக்கணும்னா LXI instruction யூஸ் பண்ணனும். இல்லனா HL register pair la address போட்டுட்டு SPHL you have to write. That's all. So push RP என்ன நடக்கும்னு பார்க்கலாமா? Yes, the content of the register pair gets pushed into the stack memory pointed by stack pointer. That's all. Yes, register pair content நீங்க என்ன register pair mention பண்ணீங்களோ whose content is pushed into the stack memory. That's all. So at first the stack pointer decrement by 1 எப்படி நம்ம call instruction சொன்னோமோ அதே மாதிரி தான் இங்கே நடக்கும். Stack pointer first one decrement ஆகணும், higher byte will get stored, higher byte of the register pair will get stored, then stack pointer again decrement by 1, lower byte will get stored now. That's all. Example, push B என்ன நடக்கும்னு பார்க்கலாமா? Kindly take a screenshot of this slide, then I will move to next slide. So first stack pointer is pointing to 8505, correct? So it is having some data, that's all. So now push B அப்படினா meaning என்ன? The content of BC register pair has to be pushed into the stack. First என்ன நடக்கும்னு பார்க்கலாமா? Step 1, content of stack pointer register get decremented by 1 so that it points to an empty location. First step. 8505 irundha enna agudhu 8504. Now higher byte of the register pair is BC la edu higher byte of the register pair. Which one is higher byte? B register or C register? Which one holds higher byte? Yes, B register 13. Very good. So 13 will be pushed into the stack. Again, stack pointer has to point the empty location. So again, it has to decrement by 1. So it is pointing to 8503. Now the lower byte of the register pair, that means C register content 57, is pushed into the stack memory. That's all. Correct? So push B, higher byte of the content is pushed, then lower byte is pushed. That's all. This sequence you have to remember. Push pandrappa higher byte and lower byte solo. What about the pop condition? When we are popping the data, how the order of popping will take place? Pop to higher byte and lower byte, or pop to lower byte and higher byte? Which order it must be followed? First pop panna kudiyadhu enga poganum? Lower byte, then higher byte. Very good. So next we will move to pop operation. So the content of the stack memory pointed by SP gets popped from stack memory to the content of the register pair or PSW. Fine. So first, the top of the stack content is moved to lower byte of the register pair. Then stack pointer points to the top of the stack. So already ஒரு data நம்ம pop பண்ணியாச்சு அப்படினா, the below memory location is the top of the stack. So it is pointing to the top of the stack. Again, that particular memory location content is moved to higher byte. Again, it points to the below memory location. That means stack pointer content, sorry, the memory pointed by stack pointer content gets copied to higher byte of your, sorry, lower byte of your register pair. Stack pointer will get incremented. Then the content pointed by the stack pointer register is copied to higher byte of the register pair. Then stack pointer get incremented by 1. That's all. In total, stack pointer is incremented by 2 during pop operation, by 2 during the push operation. That's all. Kindly take a screenshot. I will move to next slide. I will move to next slide. So there you can see the example. To consider this pop H. Pop H means what? From the stack, HL register pair content should be, from the stack memory content 5713, it has to be popped to HL register pair in the order of lower byte and higher byte, L and H. So the content of the memory pointed by SP, that means 57, is popped to lower byte of HL register pair, that means L register pair, sorry, L register. So stack pointer has to incremented by 1 to point the current top. So 57 remove panniyachina adutha data enga irukku 13 below memory location, that means 8504. So again stack pointer has to increment the top of the stack point pannudhu. Now the content 13 pointed by the stack pointer is copied to higher byte of the HL register, that means H register ku poite store aayidhu. It has to point the top of the stack. That's all. Push reverse operation na pop. That's all. Push pandrappa higher byte first, lower byte next. Pop pandrappa lower byte first, higher byte next. That's all. That's all about the push and the pop operation. Kindly take a screenshot. I will move to next slide. SPHL. The content of HL register pair is copied to content of stack pointer. That's all. So before execution, எப்படி இருக்கு? கரெக்ட்டா? HL ல 8FFF இருக்கு. Fine. So after execution, stack pointer is also copied with 8FFF. That's all. Kindly take a screenshot. We will move to the next slide. So this 3 instruction, push, pop, and SPHL. These 3 instructions are stack related instruction. So that's all about the stack instruction. Next, IO instruction. Okay, we'll see IO instruction. Okay, what are the two operations you can do with the input output device? If it is an input device, what you can do? If your microprocessor is communicating with the input device, okay, what operation it can do? Whether it can read or write. Input device na enna operation nadakkanum? Read operation or write operation? Yes, very good. Read. What it has to read? It has to read an 8-bit data provided by the specified device. In the particular instruction or address kuduthirupom, that is an 8-bit address. The very first time we are discussing about 8-bit address. Correct? So the IO instruction allows reading the data from input device and writing data to output device. There are two operations you can have. IO instruction, it can have two operations. Input operation, the other one is output operation. To perform the input operation, we have in instruction. To perform output operation, we have out instruction. Fine? In and out are the keywords. What about the instruction? In பக்கத்துல ஒரு 8-bit address. What it mean? Your CPU is communicating with many input device or output device. Correct? Out of that, from which it has to read the data. That means வெறும் in அப்படின்னு நம்ம யூஸ் பண்ணோம்னா எந்த டிவைஸ்ல இருந்து ரீட் பண்ணனும் தெரியாது. Fine? So in must be provided with the 8-bit port address. Fine? In P8, where P8 is the port address, 8-bit port address. The data is read from the port address, okay, and stored into the accumulator. In 30H abina meaning enna? Many devices you can have connected with your microprocessor, but the device whose address is 30, from that device it will read the data. Correct? That's the meaning for that. The value provided by the particular device, that means content of the port address, okay, எந்த டிவைஸ்க்கு அந்த போர்ட் அட்ரஸ் இருக்கோ அதுல இருந்து கண்டென்ட் எங்க காப்பி ஆகுது? அக்குமுலேட்டர் ரெஜிஸ்டருக்கு காப்பி ஆகும். That's all. No flags will get affected during IO instruction execution. Fine. Similarly, out P8. So in P8 அப்படின்னா meaning என்ன? From the device we are getting the data only to accumulator register. Please underline the word only to accumulator register. Fine. In அப்படின்னு சொன்னாலே வரக்கூடிய data, read பண்ணக்கூடிய data, it is going to be available in the accumulator register. Similarly, to write the data must first put into the accumulator register. So out P8 அப்படின்னா meaning என்ன? Content of accumulator is copied to the particular output device. That's all. That's all about the out operation. Clear? So totally we are having two operation under IO instruction. In operation, the another one is out operation. In அப்படின்னு சொன்னோம்னா from an 8-bit input device, we are reading a data to accumulator. The CPU is reading a data to accumulator. Out P8, what it means? Writing the accumulator content to the mentioned port address. That's all about the out instruction. So P8 அப்படின்றது என்னது? 8-bit port address of IO device. That's all. Finally, we have machine control instructions. Okay. So the machine control instruction la என்னென்னலாம் இருக்கு அப்படினு பார்த்தோம்னா, those instructions which control the operation of the CPU rather than moving a data or performing arithmetic or logical operation or performing the branch operation. Fine. This set of instruction will do a mission related operation. That's why it is called as machine control instruction. So என்னென்னலாம் இருக்குன்னு பார்க்கலாமா? All machine control instructions are 1 byte. No flags get affected while executing these instructions. The machine control instructions என்னென்ன இருக்குன்னு பார்த்தோம்னா EI. EI stands for enable interrupt. There will be a flip-flop available in 8085 microprocessor to enable the interrupt. Correct? EI அப்படின்ற instruction execute பண்ணா that flip flop will get set. That's all. That means all the interrupt of 85 will get globally enabled. Correct? EI instruction நம்ம execute பண்ணா எல்லா instructionம் enable ஆயிடும். Sorry, எல்லா interruptம் enable ஆயிடும். Clear? The execution of EI instruction enables all the interrupt. There is some condition. வெறும் EI பண்ணா எல்லாமே enable ஆகாது. Fine. So this is the first step. We have to enable all the interrupt. Apart from that, you have to do another thing that we will discuss later. Okay. So EI அப்படினா enable interrupt. DI, this instruction means disable all interrupt. Fine. Disable all interrupts. SIM, set interrupt mask. Okay. RIM, read interrupt mask. This kind of instruction you can understand once we have studied about the interrupt concept. Interrupt concept நம்ம படிச்சதுக்கு அப்புறம் இதெல்லாம் புரியும். EI அப்படினா enable interrupt. DI stands for disable interrupt. Okay. Then we are having word format for SIM and RIM that we will discuss later. Okay. So நம்ம interrupt படிக்கிறப்ப இத பத்தி பார்க்கலாம். Clear? So SIM அப்படின்றது set interrupt mask. So எந்தெந்த interruptல நான் மாஸ்க் பண்ணணும், interrupt வந்தாலும் எனக்கு ரெகக்னைஸ் ஆகக்கூடாது அப்படின்னு சொல்றோமோ அந்த interruptல என்ன பண்ணலாம்? We can mask it. அதுக்கு உண்டான instruction தான் SIM. Similarly, we can read the status of the masked interrupt. So whatever the interrupts are masked, I can read it. Fine. So அதுக்கு read interrupt mask. Fine. Then NOP, we have an instruction termed as NOP. Fine. So this indicates no operation has to be performed while executing this instruction. In the instruction execute பண்றப்ப program counter value மட்டும் ஒண்ணே increment ஆகும். That's also to point the next instruction. That's all. NOP stands for no operation. Then HLT stands for halt the program execution or stop the program execution. So these 6 instructions are termed as machine control instructions. Okay. So EI, DI, SIM, RIM. These 4 instructions are related to interrupt and the 2 are related to a general operation. Fine. NOP அப்படினா no operation. Fine. See, this kind of instruction, NOP operation can be used when you want to replace or when you want to remove a byte of code from your program. நீங்க program எழுதிட்டே வரீங்க, அதுல ஒரே ஒரு பைட்டை மட்டும் நான் வந்து தூக்கணும், ஒரு particular instruction மட்டும் நான் remove பண்ணனும் அப்படினா you can replace that particular instruction with NOP. Clear? So NOP instruction ஓட usage புரிஞ்சுதா? See, ஏதோ ஒரு instruction எனக்கு ப்ரோக்ராம்ல இருந்து ரிமூவ் பண்ணனும். அப்ப என்ன பண்ணனும்? again நீங்க வந்து reassemble பண்ணனும் program. Fine. Instead of that, what you can do? In that particular memory location, we can put the opcode for NOP instruction. The opcode for NOP instruction is 00H. That's all. So எந்தெந்த மெமரி லொகேஷன்ல உள்ள இன்ஸ்ட்ரக்ஷன்ல எனக்கு தேவையில்லைன்னு நினைக்கிறோமோ ப்ரோக்ராம் மாத்தாம அந்த இன்ஸ்ட்ரக்ஷன் மட்டும் நான் ரிமூவ் பண்ணோம் அப்படின்னா I can insert NOP instruction. Fine. ப்ரோக்ராம் எழுதிட்டே வரோம், இடையில ஒரு லைனை நம்ம விட்டுட்டு அடுத்த லைனுக்கு எழுதிட்டோம் ப்ரோக்ராம். அப்ப என்ன பண்ணலாம்? In between memory location you can fill with NOP instruction opcode. That's all. Fine. So that's all about all the group of instructions available in Intel 8085 microprocessor. So இன்னையோட instruction set முடிஞ்சது. 8085 instruction set complete ஆ முடிஞ்சது. Okay. So far we have discussed 5 types of instruction groups. Okay. Can you people type it in the chat? என்னென்ன group of instructionலாம் பார்த்தோம்? Data transfer group, very good. Then branching group, very good. Then வேற என்னெல்லாம் பார்த்தோம்ப்பா? Data transfer, branching, logical, arithmetic, very good. Fine. The last one is stack, IO and machine control instruction. So adula ipo nama paathathu machine control instruction. So that's all about the Intel 8085 instruction set. Fine. If you people are writing, if you people want to write the assembly language of a particular microprocessor, you have to go through the instruction set of the particular computer. ஒரு particular processor யூஸ் பண்ணி நான் வந்து ஒரு application create பண்ண போறேன், அதுல assembly language எழுத போறோம் அப்படின்னா definitely you have to learn all the instructions of your microprocessor. Fine. Okay, now you people aware of it. What is mean by instruction set? Fine. What about the use of each instruction? Everything you can do. To write any program, we must use instructions in a sequence so that the program aim can be achieved. Is it clear? Is it clear or not? Yes or no? Fine. So that's all about the instruction set. Now I will give a brief introduction about the mission cycle and timing diagram of 8085 microprocessor. Okay. So this is the last 4 session பார்த்தது என்னது instruction set of 8085 microprocessor. Okay. I will assure one thing. Okay. In a live recording, I am assuring. Okay. All the instructions are covered in the particular 4 sessions. Fine. So the instruction set நம்ம ஃபுல்லாவே கவர் பண்ணியிருக்கிறோம் நம்மளோட இந்த particular கோர்ஸ்ல. ஃபைன். மோஸ்ட் ப்ராபபிளி எல்லா இன்ஸ்ட்ரக்ஷனும் நீங்க ஸ்டடி மெட்டீரியல்ஸ் எங்க ரெஃபர் பண்ணாலும் எல்லா இன்ஸ்ட்ரக்ஷனும் ஒருங்கே இதே மாதிரி கிடைக்கிறது ரொம்ப கஷ்டம். சரிங்களா? ஸோ டோன்ட் மிஸ் அவுட் திஸ் வீடியோ லெக்சர் அண்ட் யுவர் ஹேண்ட் அவுட் மெட்டீரியல். கிளாஸ் ரூம்ல இன்ஸ்ட்ரக்ஷன் செட்டுக்கு ஹேண்ட் அவுட் மெட்டீரியல் வி ஆர் போஸ்டிங். ஃபைன். ஸோ அதையும் வந்து மிஸ் பண்ணிடாது. 8085 மைக்ரோப்ராசரோட ஹோல் இன்ஸ்ட்ரக்ஷன்ஸ் எல்லாமே கவர் பண்ணிருக்கோம். Fine. Okay, now we will move to the mission cycle and timing diagram. Okay, adena sir mission cycle and timing diagram. Definitely we are going to have a diagram. Okay, what is mean by timing diagram? With reference to time, we are going to represent the status of all the signal. Okay, so over T state layum ஒவ்வொரு இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் ஆகிறப்பையும் ஒவ்வொரு கிளாக் பல்ஸ்லயும் என்ன நடக்கும், that is a pictorial representation of a operation. Whatever the operation takes place in the CPU, it can be pictorially represented. Fine. That we call it as timing diagram. Okay. Then what is mission cycle? Mission cycle na enna sir? To execute an instruction, several operation takes place in the CPU. ஒரு இன்ஸ்ட்ரக்ஷனை எக்ஸிக்யூட் பண்ற அந்த நேரத்துல நிறைய வேலைகள் நடக்கும் உங்களோட CPU. ஃபைன். ஈச் ஆபரேஷன் இஸ் டேக்கிங் சம் டியூரேஷன், தட் we call it as a mission cycle. A simple operation that can be done by your machine, okay, which are combinedly used to complete an operation of an instruction. Okay, fine. So obviously the heartbeat of the microprocessor is the clock pulse. Fine. So என்னோட கிளாக் பல்ஸை வச்சு தான் அது என்ன பண்ணுது, ஃபங்க்ஷன் ஆகுது. ஸோ இந்த பர்டிகுலர் ஆப்ரேஷனுக்கு அப்புறம் திஸ் ஆப்ரேஷன் ஹேஸ் டு பி டன். ஆஃப்டர் திஸ் the next operation has to be done. It's a sequential thing, correct? Fine. So definitely microprocessor operates such that the clock is the reference for timing. Okay. The next thing, each and every operation inside the microprocessor is under the control of clock signal. Correct? So எல்லா ஆபரேஷனும் எதோட சிங்க் ஆயிருக்கும், clock pulse ஓட தான் சிங்க் ஆயிருக்கும். Correct? So clock is very very essential to a microprocessor as it is a sequential machine. What is meant by sequential machine? What is meant by sequential machine? It will do the operation in a sequence, one after the another. Fine. The predominant operation done by any CPU is fetch the opcode, decode it, and execute it. Fine. Three things predominantly done by all the microprocessors: fetch, decode, execute. Fetch, decode, execute. This particular operation is for a single instruction. Similarly, it will do for the all instruction. ஒரு இன்ஸ்ட்ரக்ஷனை எடுக்குது, decode பண்ணாதான் அதுக்கு மீனிங் தெரியும், then it will do the operation. take the command, understand the command, execute the command. That's all. Fetch, decode, execute. என்ன பண்ணணும்ன்றது மெமரியில இருக்கு. அது எடுக்கிறது fetch, output fetch. Correct? Next என்ன பண்ணணும்? It has to decode the particular instruction. அதுக்கு தான் instruction decoder இருக்கு. Fine. The last thing is execute the operation. That's all. So the clock signal determines the time taken by the microprocessor to execute any instruction. எந்த ஒரு இன்ஸ்ட்ரக்ஷனா இருந்தாலும் அதோட execution time எதை depend பண்ணிருக்கும்? The speed of the clock. Correct? If the clock speed is more instruction can be executed in a single second. Fine? If the clock speed is slower, the number of instructions executed per second will be reduced. Correct? That means the speed of execution of the microprocessor directly depend on the clock pulse. So we all know if the crystal frequency of 8085 microprocessor is 6 MHz, then the operating frequency of 8085 microprocessor is 3 MHz. This and all we all know very well. Right? Okay. Now we are going to see so far what we have discussed is clock. We are stressing the signal clock. The timing diagram la edu namakku reference signal la irukka podhu appdin paathomna the clock pulse. Fine. That's why we are stressing clock is very essential to a CPU. Fine. It is going to determine each and every operation takes place in the sequence, one after the other. What is going to happen? Okay, sir. In the instruction execute aidichu. Next enna nadakum? Next. Those things are depend upon the clock signal one. Fine. So first we have to know T state na enna theriyum. Already in the word nama explore panniyachu. Can you people type it in the chat? What is meant by T state? When we are handling the ALE, there we have displayed timing. No, not toggle, Sajis. Kindly think and tell. Diagram paathe sollaam. T state appadina enna mark pannirukanga paru. One T state. Clue is also provided. The diagram itself. Yes, time period of the clock pulse. Fine. ஒரு single cycle அப்படின்னா off time, on time. Again, what it has to do? On off. That means either the time period between two successive rising edge or falling edge. Clear? So this we call it as rising edge. This we call it as falling edge. In the rising edge kum அடுத்து வரக்கூடிய rising edge அதுக்கும் இடையில உள்ள time difference தான் என்ன சொல்றோம்? T state. Yes, very good. The time interval between successive rising or falling edge. Very good, Dixon. Very good. Okay, I don't understand Kavya stream machine abin potirkinga. Okay, fine. So the operating frequency of the clock pulse we are saying. So அதுக்குன்னு ஒரு டைம் பீரியட் இருக்கும் இல்லையா, நம்பர் ஆஃப் சைக்கிள்ஸ் பர் செகண்ட், அதுதான் ஃப்ரீக்வன்சின்னு சொல்றோம். ஃபைன். த டைம் பீரியட் ஃபார் சிங்கிள் சைக்கிள் தட் வி கால் இட் அஸ் டைம் பீரியட் ஆர் டி ஸ்டேட் ஹியர். ஃபைன். So it is defined as the time interval between successive rising edge or falling edge of the clock. So T is equal to 1 by F. That's all. Time period of a clock pulse is nothing but inverse of your frequency. Yes. Okay, with this slide we will stop today's session. Okay, we will continue the remaining topic in the next session. Okay, I think roll number 19L133. 19L133.
Sir,
he switched.
Mohammed.
Yes, sir.
Yes, I think you have turn on your camera. Kindly.
Yes, sir. Sorry, sir.
Okay, fine. Okay, fine. So with this, we will stop today's session. We will continue the remaining in the next session. Okay. Thank you all of you. Adeline ma'am, please wait. Those who have given name to take seminar, please wait.
Sir, roll number